Welcome all in a video presentation of use of pitch lines in grading of irrigation channel using civil3d. My name is Mihi Sonichi and currently I'm at design unit with drafting and design center. In the class we will going to explore industry prone design techniques that will be leading us to have more accurate, more dynamic, and more functional design using civil3d. People with some site grading experience would be nice to have it. That would be add-on. When I say accurate, dynamic, and functional, this has to be correlated with construction, such as allowances for vehicles, how you're gonna compact it, and all these other issues need to be considered in creating design. Who is this guy? With more than 2 years of civil engineering role, I have worked with state government. 1 year I have worked in a highway site coordination role as a site engineer. 4 years in an academic with a School of Civil Engineering diploma teaching graduate and undergraduate student in a civil design subjects. More than 2 years I have spent in a survey, design, drafting, production in various small companies. Currently with drafting and design center. I'm a user of civil3d since 2002, and as the day goes and goes, I like to develop more skill into it. I have worked on a site area from 51 square meter to 500,000 square meter, providing inputs in hydraulic analysis, road design, traffic engineering, bit of a small structural engineering side, as well as water quality and hydraulic investigation. What is a drafting and design center? This company is very young and dynamic company based in Melbourne. In Australia, we provide and sometimes coordinates depends upon the size of the project. We providing the services in a following given area. You can read by yourself. That includes road, drainage, sewer, hydraulic, earthwork, farm, pavement, river, and water sensitive urban design. We are going to expand our reach to overseas country, mainly providing a product trainings as well as consulting services in civil and structural engineering side. And that's our future goal. What contribution up till now I have worked on a major project. This is just highlight of it. Conceptual planning of Gateway Motorway as well as Red Lane Subarterial Corridor project. Both projects were at concept stage to the detailed stage, how involved in providing a geometric traffic and mainly on drainage design investigation using 12D as well as civil3d softwares. The client was Main Road, Queensland, Australia. Baillian irrigation farm design, about 400 hectare of farm which include preliminary planning, stormwater design, earthwork design, pump design, structure design. The client was land farming to perfection, not construction, in Melbourne, Australia. Raymond Terrace subdivision development, around 200 hectare with more than 200 homes, include water sensitive design, road and drain design. The client was Lamotti Group, Newcastle, Sydney, Australia. Some of the commercial and industrial development ranging from 51 square meter, 35,000 square meter, with a consulting company called Apex Engine, a Sydney-based company. Various clients in Sydney that included drainage design, water quality analysis, and report writing for hydraulic analysis. Millbrook Farm, I was involved in a regional Victoria designing a pressure pipe for 2 km long, included pressure pipe network pump design. The client was Sharon Irrigation Improvement Private Limited. So these were the glimpse of some of the major projects I have worked on in a certain area. Let's get back to today's class, which is the project I was involved in. While the scope I can describe shortly as demolish the existing channel and design and construct a new irrigation channel. The length was around 1 kilometer. Mainly using the civil3d, we're gonna explore how we're gonna use civil3d in channel design. Few steps I can see which are: we first have to connect the survey points and create a surface. We may have to add the point. We're gonna see that later on. Once we finish that step, then we're gonna size the channel for given flow using civil3d. Basically, when I say sizing, is all about deciding geometry, depth of the water, normal water level, hydraulic grade line. Create a channel corridor using civil3d. Create a banks using feature lines. Create a combined surface and natural surface to measure the earthwork volume. So this was the site. As you can see here, existing site there, I created a surface, and this is a cross section of channel. The way a lot of irregularity. Using civil3d, I created this. Can't zoom in well, but this cross section, which is nothing but the sand line you can see here, is a natural, that is a ground surface. Above that line we propose one pad surface. We dig the channel 0.45 down the pad surface, and then we created banks 2-in-1, 0.6 meter wide, 2-in-1, attached to the existing trapezium of the channel. So the channel is around, I can see, is 1.1 meter deep from top of bank to bottom of the channel, and having 2-in-1 side slopes both way. So as you can see here, that will be more clear in a profile view. So you can see here that this is the channel bed, the green line. This surface is a natural surface, and the natural surface is very irregular. As you can see, it's going up and down. I then created a compacted finish surface, which is, I call it the pad surface in here, and then I dig down the channel and created a bank using civil3d. And then lastly, we're gonna measure the volume of earthwork and always, once you have any question, you can send an email to us at draftinganddesigncenter@gmail.com. So let's get back to the project work. We open up the file page, many files here. Basically, there are survey data I obtained from survey. As you can see here is the channel cross section is measured along there is an existing channel. We gotta fill this channel and create a new nice channel which can accommodate certain discharge and design and construct the channel. So the main, without going more into detailed technical aspects, I'm just gonna highlight the main steps in Civil 3D. Basically, we focus more on a feature line, how we can create trapezium shape, the one I shown earlier, and how we can measure the earthwork volume. So this is the channel here. So the first step is to create a surface. So whenever I create a surface, it's a good technique to create a new layer. Which call as a surface. So let's say my surface is gonna be natural surface. I will call it as a MS. So I created one more layer. It's already in use, so I don't have to worry about. Okay, so right click, create a surface, which I call as natural surface. I will then add this surface into the natural surface layer. It is always easy. Later on, you can freeze the surface if you don't want to. So okay, I can add all the point which has been surveyed. I hope every one of you been aware about this thing. Some of the point which are duplicated, they ignored. You can click the surface and see how it looks like in a 3D. As you can see here is these are the channel. This is channel surface. This channel is going on. Okay. The base thing would be I can delete this surface first and let me just create a surface for channel, which is this points only, which is here. You can click the point, edit the point list. You can see row description as a X, and then you can create a one more new group which can represent the cross section of the channel only. So there, I hope all the points are X. Let me see it again. Row description is X. You can then create a one new group which represent all survey point along the cross section of the channel. Creating a new point group, which is the existing channel. Okay, so all point had a row description of X. So then I will click the point here, right click it, property. I will include all the point had X description, and you can see in the point list all profile points, all cross-section points are included. You can create a one group. Again, you can create a surface. That time I will call it the channel surface. I will create one more layer which is channel. Existing channel, better. Okay. Sorry guys, I am a bit fast, so if you don't know anything, you can always send an email or ask question. Okay, so I can put a description existing channel. Okay, now is there, I can add the group which I created for the point along the channel. Existing channel points, I'm adding it and creating the surface along that point. So now this represents only the cross-sectioning point which has been surveyed. You can look at a 3D view. This is a channel is going on. You always have different shapes if you like. So that's irregular channel. You can have a cross section of it at a certain point. Yeah, so that's the first step, is just to we created a surface of the channel, existing channel which is irregular. You can draw the cross section along entire channel. I use the tool called ARD for that. I can go into the it's slow, sorry about it. It's not moving. Don't know what went wrong. Not responding. We got an error. No, let's go back to go back to the channel which shows the drawing. Sorry for that, guys. Okay, got back to this point. Okay, so we have to repeat the steps which we already did before. Okay, so as I said earlier, this point represents existing channel. We need to create the surface along it. So I'm creating a surface. To do that, I need to create a point group. But before I create point group, I have to create a new layer, which is existing channel. There's no layer here. Existing channel is there, then you close it, and then you can create now a new group, existing channel. You can include the point with a description of X, all points here. I can now create a surface of existing channel by clicking the layer which I already created. Existing channel. I can add all points of existing channel. Let me turn off this contours. Going in the property, I can turn off the contours and just keep the border highlighted. It's easy to work on and doesn't look too messy. Okay, let me look with that. Okay. Okay, so this is existing channel, guys, as you can see in object viewer. Okay, now I want to do drafting of cross section along that. Basically, as you can see here, these are the fence point. So I will just quickly join the fence point by creating a new layer called fence, so that it just help me to have understanding of where is the fence for construction point of view. Fine. One fence post is here. Okay, there's one fence post is here. I'm just randomly connecting the fence point. And the one fence post is here. And basically one more fence point is here. And one fence point is here. Okay, so this is a fence line and this is my existing surface of channel. I'm just creating a centerline alignment of the channel, which definitely gonna be somewhere else at that point in here. So I'm just creating a layer. Okay, so P-line to create the alignment of the channel. What I'm doing, guys, is once I create this surface, I'm drafting the cross section of it. So this is the center line of my channel. Okay, I can go in alignment, create alignment from object, click say yes. It will ask you which side you want. I'm expecting it, and I'm putting a center line or channel. With no label, nothing at all. Okay, so that's my center line alignment without change. It started from here. We don't want any speed, just delete that. It starts from here going down that way. If I want, I can reverse the direction, then it will just ending it here, which I wanted. So once I create alignment and I want to have cross section of this surface, I can now go into the add-on software called ARD, Advanced Road Design. And it's a bit slow here, but I have to create a surface which is existing channel and save exit, and then I can go into the string profile. It will ask me the string surface is existing channel. Say okay. Basically, it will give me the shape of the profile, which definitely we don't want to explore right now. I will go to the cross sections, which is for the cross sections alignment, which is here. All sample sections, and it will itself consider the changes and giving us the, you can change all the settings here. You can load the style, here, and you can zoom in here. Basically it will give you is nothing but at every time it gives you cross section of the existing channel along the alignment. As you can see, is a bit of a zigzag in a channel, and we're gonna put a new channel in here. So let's say enter and say plot to layout. And then we got few sheets of the cross sections of existing channel. You can see here. Okay, so that just to present how add-on application called Advanced Road Design works with civil3d. Okay, now as I created a surface of the channel, I need a natural surface connecting to the edge point here as well as in here, so that I can cut the cross sections. As you can see that to create a natural survey, there is a point called spot level is been already surveyed. So that's description is 601. So I will go back to the step of creating a natural surface, which is create a one more layer, which is new layer called as a natural surface. and then I will go back to point group, create a new group which is called as a 601, was it, natural surface, and then includes only 601, 601, 601 is the point natural surface property. You can see that all the points of SWOT level got there, and then I can create a new surface which is nature surface. So now we have existing channel surface and we have nature surface. New surface which is nature surface, and yes. Then I can add the all points of natural surface. NS. Okay, so I gotta have two surface. The one is the natural surface and the one is the channel surface. As you can see, I can click the both surface now and have a look at it, how it looks like. So what is that is, this is a channel surface, and then there is a natural surface. So channel bank resting on a natural surface. So we have to create add few more points in here to create a natural surface. So I'm just going to do that. I just go to surface and then add this surface tile and highlight the points. As you can see here, and I do want to have this point to be added, which is the edge of this surface channel bank. So I can click add point, this new elevation which is 99.28, and then keep adding the point for fences as well as the channel. This point elevation is 99.262, and this point elevation is 99.32. This point elevation is 99.21. And this point elevation is 99.18. .05. Okay, well, I'm just quickly moving on with these points, and then 98.92. Didn't work this way. Here. 9.14. That looks okay a bit. And then I have to add the fence point, which I don't have much time, just to create a group. Same procedure as we discussed below. So now we have two surface, existing channel surface and we have a natural surface. So when I click both surface and look in object viewer, this is how it looks like. we extended this surface cutting to the channel, because our objective is just to get rid of the channel, create a new channel, and cut the ground and fill the ground as well. So this is the existing channel, and the natural ground we extend a little bit by adding the point, cutting the banks, going across the channel and going to the other side. Okay, so now we have to create a sizing. You can size this channel for different discharge. Well, I'm not going into the technical details, but there is an option called design and launch express. And this is a there are various and variety of hydraulic analysis tools. It is your choice which tool to be used at what time. My channel, I want to shape it as a trapezium. Let's say my bed width, I want to keep it as 2 meter. Side slope 2 in 1. Depth, I'm just trying to put 0.9. Total depth is 0.9. Elevation, which can be, you can put 99 right now. Slope 0.03%. The end value, you can look it up. I'm putting 0.03 and run the analysis. Basically, I'm not putting side slopes 1. Okay, so my discharge, let's say, is 15 megaliter a day. I need only 0.3 meter of depth, for that discharge, and additionally I need 0.3 meter of freeboard. So as I presented earlier, you can size the channel likewise, and then what I did is I estimated my sizing of the channel likewise, and then I determined that I need only 0.45 to have that discharge of whatever I wanted, plus 0.3 meter. I dig the channel, existing ground, fill both banks, and created a bit of a hump, which is 0.5 or 0.3, whatever it is, 0.3 here. So total is 0.75 deep for my given quantity of flow. So for the ground natural surface, which is, you can see here is a sand line, I then raise my surface and compacted by creating one more pad surface. From that surface I created 0.45 deep and excavated the ground and filled both the banks in here, 2 in 1 side slopes. So I hope you understand that. So basically we're gonna do the same thing in here. Once we create an alignment, I need my channel to be, I'm not going into too detail about hydraulic sides, but I need my channel to be 0.45. Dig it down the natural surface, pad surface. So I'll then firstly go in civil3d, create a profile of my alignment, surface profile, natural surface, alignment of channel, okay, and I have to do the profile view, natural surface, So this is the nature surface profile. As you can see, it's going down like that. I'm creating one more surface which is just slightly above the nature surface, which I call the pad surface. Or you can use this nature surface, put your 0.45 down the channel. So let's just, I'm going to use this nature surface as a profile, and I'm taking the nature surface which is here 0.45 down. So I will create a channel shape which is going in two parts. Ready to go. Okay, channel. Okay, firstly we have to create an assembly, which is the basic assembly. Basic. Okay, well, it's not there. And lens. So basic. Yeah. For daylights, we can show the. Okay, I need the basic assembly though. Generic. Okay, here we go. I need a marker point first. So what is it? Marker point. Assembly. Well, I need an assembly as well. Sorry. Okay, why is the assembly? Assembly metric. Yeah, here we go. I gotta first put a null assembly, which is here, and then I gotta put a channel, which is oh yeah. Okay, well I want that to be 0.45 below the ground level. I don't want any lining. It's up to you how you're gonna change everything. I just simply need trapezium underneath the channel. This is a small channel, 2 meter depth, 2.45 depth, 2 meter width, 2 in one side slope, and always click the help as needed. Okay, side slopes, so that's here. Sometimes it's 2 in 1 and 1 in 2, so 1 in 2. Aligning depth, I don't want it. I don't want extension height. I don't want width. I don't want that. Don't want this one. Don't want this. Don't want this. Apply. Okay. Here is my basic simple assembly. Oh shit. Okay. Here is my basic simple assembly. 0.45 deep. 2 in 1 side slopes. You can measure it using a line. That. Do this. 145, yeah. So all looks good. 21 side slopes. Yeah. So basically from that point you can create a corridor. Channel design. You can have a new layer if you like. Design channel. Always have a good habit to create a layer. Profile is the existing surface and assembly is the one we created. Target surface is also existing surface, and let's say OK. And then those who are aware about this thing, they should know this is just basic corridor modeling skill. Okay, so here is our channel, which is okay. Well, that thing shouldn't be occurring, which is here. This thing should not be there. Basically, sometimes it is outside the surface, then this thing happens. Okay, so now you can check it again. This there. Hold on, I'm not sure what's going on here. Okay, well, my surface is up to here and my channel extends up to here, so that is also issue. This thing is going on. I have to extend my surface up to here, natural surface, but I don't have sufficient time right now. This surface, natural surface we created by adding the point, has to be extended up to the end. Now if I look at thing looks pretty clear. See, and then I can click both together, so you can see the nice channel underneath the ground. Basically it's attaching to the ground right now, and you can see the channel underneath the ground. Yeah. Okay, now what we need to do is we need to create this shape. This is what we are after since long time, aren't we? Feature lines. So we created this shape, which is 0.45 down. In here we need to create this shape using banks. We're using feature lines. So to do that, I just need to click on a corridor, create a feature lines from corridor, click on here, and then you can say that design channel. Always appropriate names helps you to recognize the thing later on, and then you can say okay, you can click this one. So by adding that, we are creating the feature lines for each of it. Okay, all done. So all feature lines are here. All these shapes has a feature lines. I can click the feature lines which I created here, and what I need to do is I need to Okay, this feature line is here. This feature line is here. Okay. Okay. Well, this feature line. Okay. Well, I shouldn't be doing feature line. First, I have to create a surface. Okay. So that's good. I can create a surface from the corridor. Top surface. Okay. So what we got is we got a top surface. Let me turn off the point so that the point doesn't appear all the time. Okay, what we got here is surface on the corridor. So this is the surface of the channel which we modulated 0.45 deep down the ground. Then I will create a feature lines on a surface. Feature line, create a feature line, design channel. Design. You can create a channel design layer. Channel design channel. You can click the surface and accept the point elevation which is same as on a surface, or not this one. We should be at pitch line. Click the point in here, accept the elevations, and keep doing that. So there will be a feature line on the top edge of the banks. Okay, I am just quickly running it. Don't have sufficient time right now to connect the points, everything. The object is just to create a bank, so I just create a first and last point mainly. Okay, so this should be on a surface. Now, what do we want? We want to be this line. At that point, we create a feature lines. We need to offset this to have 2-in-1 slope. We need to offset this by 0.6 and raise it by 0.3 to have 2-in-1 slope. So offset this feature line on this point by 0.6. Okay, offset this by 0.6 and raise this by 0.3. Okay, all sort of thing you can do by here. So I want to offset this. Step offset. offset this by 0.6. So, point offset distance, which is 0.6, side, which is here, and elevation difference, which is 0. Okay, raise this by 0.3. So I just click back to here, and then I raise or lower, click on here, 0.3, 0.3, offset this again by 0.6. So step off again by 0.6. Sorry, I'll do it again. Offset this by 0.6. And it will ask you how much offset. 0.6 is already there. Enter. Side, which is here. Elevation difference 0. And then raise down. Okay. Again, offset this by 0.6 and raise down by 0.3. Again, offset this. Okay, let me do it again. Again, offset this 0.6, side here 0, enter, and then we got to this point, which is up in here, raise down by 0.3, and then raise it down by -0.3, minus 0.3. Okay, now we should have this bank created, which is this to this 0.6 meter wide, and this 2-in-1 size slope attaching to the channel surface 0.45 down we created earlier. So we then create a surface called bank. Each time new surface, new layer, looks good. Okay, so add the brick lines, which is banks, this, and this. Enter. Okay, now we should have that nice and tidy trapezium shape using a feature line. As you can see here, we did it. Let me cover all. Southeast, turn around, zoom in. Okay, this looks a bit nice. Okay, well, okay, I'm not sure actually this is shape. So what we did, we created a switch lines on the channel, the 0.45 down, and here we raised it, offset it, again offset, and lower it down. So we have that channel shape ready. You can see now it's a bit clear, different shapes. Elastic, sketchy. Okay, the same you can do it other side. You can merge two surface by creating a new surface called design channel with banks, create a new layer as we discussed. Okay, and then once you create that design surface with the banks, you can have paste surface. The first surface we created was existing top channel, and then you can paste that into the banks. Where was the bank? Yeah, banks. Okay, so by creating that, you're gonna have the final surface which is combining of two. So let me have same procedure you can apply on a right banks. So let me just do the cross section. Same, I use add-on application called ARD. So I have to define that surface which is design channel with the banks as a default. Banks, save, exit, and then let me see that it is already there. Design channel with the banks. Okay, and then I go in cross sections, all sample sections. Okay, as you can see here, let me zoom in. So you can see a 2-in-1 slope here, and I created up to here. I had earlier modulated. I created a pitch line on here. I then offset it by 0.6, raised by 0.3, offset it by 0.6, offset it by 0.6, lower it down by 0.3. By creating that, I created one more bank surface. I merged this top surface of channel with the bank surface, and you can do the same thing on the other side to create trapezium, and then you can measure the quantity of earthwork using civil3d. I hope this video is interesting. We have seen a little bit of introduction of how we can apply civil3d in entire life cycle project planning to little bit of construction aspects we looked at, and how we can optimize earthwork and lower down the construction costs using pitch line grading and application as well. I hope this video will be interesting to you, and any feedback you have, always welcome at drafting and design center at gmail.com, which is here. Once again, thanks very much for watching, and bye now.